Hello guys. So in this tutorial, which will be our tutorial number 4 for our basic TensorFlow playlist, we are going to look into the details of TensorFlow datasets. And once we'll be familiar with TensorFlow datasets, we'll go dig deeper into TensorFlow datasets in next couple of tutorials. Before jump into let's say CNN and LSTM or GRU tutorials or transformer tutorials. I think this is much more important to understand how to load the data for efficient machine learning model building. So first thing that I need to address that why you will be requiring this TensorFlow dataset module and why it is important for you to learn basically this TFDS thing, right? So if you see that you have data in particularly this 6 or 7 formats basically where you have your machine learning task mostly around this. So you'll have images for classification, detection and all. You have structured data for your regression and recommendation analysis. You will have some sort of NLP task with your text data and translation basically. You'll also have your video data for uh, the motion detection, object tracking, okay, license plate and all. And you have your audio data for music recommendation, let's say, or audio segmentation, or that for that matter, time frequency analysis and all, right? So it's a huge volume and huge variety of data, and this variety comes from a lot of separate vendors basically. And in practical world when you work, you will not get a simple Kaggle data, right? You will get data from varieties of vendor, varieties of different organization. So what this TensorFlow dataset does, it gives you basically it provides you some API to seamlessly integrate data in your platform for doing machine learning with the with help of their APIs. So by using TFDS with very less line of code, you can implement huge what I mean basically you can implement a large big data machine learning data processing basically. And you can segregate the processing like in case of people who are familiar with data engineering terminologies, they knows the term ETL, right, which transcribes for your extract, transform and load, right? So this thing also can be possible with TensorFlow dataset. So today in this tutorial, we'll be doing how to do ETL with TensorFlow dataset, and how by doing ETL you can easily build machine learning models and some of the specific use cases of TFDS at the very preliminary stage. Okay, so let's get started. So this is the notebook that we are going to follow. First, we are loading TensorFlow and then we are just printing the version of the TensorFlow. Okay. So once that is done, yeah. So once our TensorFlow version is loaded, TensorFlow is loaded basically, and it has a 2.15 version in our current notebook. And then we are going to import TensorFlow datasets and matplotlib for showing one example, nothing else. It will be very basic tutorial, so you can only learn the, you can say that it's a hello world of your TFDS example, right? So ETL, as you have already mentioned, extract, transform and load. So we are going to perform basic ETL using TFDS. Okay, so extract means extraction means fetching the data from the source, right? So TFDS, how TFDS performs any loading data from the source is with the load method. So if you can see this tfds.load. So if we go to all the APIs and if you can expand TFDS, you will find this load API here. If you click, you can see all the details required. So name of the data set you want to load, is there any split available? If it is available, then which split you want to load, then data dictionary, batch size, all these are optional parameters. Okay, and you can also build from the builder basically. So how your basically how you can build that one is your tfds dot load. You will actually follow first one, the builder approach. It will build the data set, okay, the core data set. Then it will generate and prepare the data set, so this download and prepare method. And finally it will bring you all the details as a TensorFlow.data.dataset instance using this as dataset method. So internally, these three convenience method it performs when you apply a tfds.loads. Okay, so it is not a simple method. It looks very simple, but underneath it performs a lot of more what like this operations. So for the very safe instance, what we are going to do, we are going to load the data Mnist dataset, fashion Mnist, and we are providing the split as train. So it will load the train section of the fashion Mnist dataset, and we are calling it using this load method, right? So you can see as it is already being pre-cached, it is loaded the dataset. So how you can visualize or how you can verify. So now if you call dataset, you will see that a dataset instance has been created. Okay, and what it contains, as you already know, that Mnist contains the fashion data of 28 cross 28 grayscale data that has unsigned integer character, and the levels are also tensor of type integer, right? So we have 10 levels here. So next part is transform. So once your data set is available with you, then you can use shuffle method or repeat method or transform method. There are multi map method for transformation. There are various methods available that we'll see in the next set of tutorials. So for this tutorial, we are going to use only a simple method, which is basically shuffling your data set with the predefined buffer size that we have provided here as 100. So your dataset dot shuffle and 100 will do a shuffling of the first 100 instance of this dataset, and it will hold the random 100 values. Okay, so once you run, you will see the output. Okay, so you can see the same dataset, elements underneath the dataset. So it's so previously it was prefetch dataset, right? And then it changed to shuffle dataset. So you can see now your shuffling happened successfully. So your data first it got extracted, then it got transformed, right? Now the third one is load. So load means loading into disk. That is also very simple and very separated from both the operations that we have performed so far. So for doing loading, let's say we are going to use this take method. It will take so it's kind of a iterator kind of approach, where it will take only one instance from the example data set, right? So we have already used a shuffle method right before it. So just a simple for loop. So for some instance in the data set, take one. Okay, so take the first element basically, and once the element is available, that element has leveling as image and level, right? Where you can find here, right? You can see that we have image and level as the keys. So you can use the key, and then you can use numpy and squeeze method. Squeeze method is required for plotting this image, because the shape here in this predefined data set for Mnist data is 28 cross 28 cross 1. So this extra one you need to remove before plotting into a 2D space, or else it will throw you an error, right? So that's why your squeeze operator comes, that will squeezing any additional dimension that is not effective in the tensor. Okay, so once that is done, you can simply use whatever we are going to use for very long time right now. So this image show or im show method of your matplotlib library, and you can show the first image uh, in the data set, and you can also print the level. Okay, so this is a very basic ETL approach that we have seen, but it covers all the aspects what TFDS can do, and which is very much you can say uniform and very less line of code, and the codes requires for various input sources are also same. So this is a I mean you can say a very homogeneous and less amount of code we have to write with TFDS to perform any ETL pipeline kind of operation. So later on, when we will build pipelines for data modeling, we will see how easy it becomes with TFDS to maintain all the codes and do different approaches, right, and reuse the codes basically. And here I have just shared one simple example of model building using this TFDS. So for that you require this to follow along with this coding exercise, right? You will be requiring this TensorFlow dot add-ons. So once you have that installed, okay, you just install it as TFA, TensorFlow add-on. Okay, and for loading any data, as we have already mentioned here, right, you require tfds.load method. So I'm using same tfds.load method, and here I'm passing another dataset's name, which is horses or humans. So once we have passed that one, we are for training data we are providing the split as train. For testing data we are providing the split as test. And to make the data much more numpy versioning, we are providing this as supervised equals to true flag. So once you will be providing this flag in this method, it will create a same numpy kind of a structure for your data set, or else it will return you dictionary like this one. So here it will return you dictionaries, right? But here once you mentioned that you required in a supervised format, it will provide you the in the tuple format. Okay, so once it is done, let's just run this. So your data and validation data is loaded. So now as part of your, let's say, transformation, so after E your T comes for transformation. What you can do, you can shuffle the training data to reordering the order of the images present in this data set. So same thing, we need to provide your data dot shuffle, and then provide the batch window basically, which is 100 here. And once that is done, then you do a batching with a batch size of 32, right? So why you required batching? For improved training, right? For optimized training, you need to provide some batch size, right? So you can also change it to 664 or whatever, like whatever fits your need. For this example we're using 32 here, and same goes for validation batches. So for validation batches we don't need shuffling, right? So we can only do the batching with 32 batch size. So once this our training data and validation data set is ready, what we can do, we can create one sequential model using CNN architecture. So first will be our convolution. Same thing, the number of filters. So here we are passing 16 number of filters for the first unit. The filter size will be 3 cross 3. Then the activation will be ReLU, and the input size, as you can see from the data itself, will be 300 cross 300 cross 3. Okay, so how to see that one? So for seeing that thing, same thing you just paste. Let's say I'm just giving you one example. Load. Okay, now let's just click train with info equals to true. We have to pass. Okay, and it will come with one info. Okay, so once you will use this one, this method and this parameter, basically the method will be same, your parameter is only different, right? With info, so you can get all the information. So now if you plot this, print this info value, you can see. Okay, so here you can see the input shape is 300 cross 300 cross 3, and there are two number of classes. Number of examples in test are 256. Number of examples in train is 1027. There is two shard getting used for training purpose. For storing the training data. For testing, there is only one number of sharding happened. So everything, who is the owner of this repository or this data set, from where we have taken it, everything you can see here, right? So this is one trick you have to remember, how to visualize the requirement or metadata information for any TFDS dataset. We'll also describe that later. Okay, so once this model is built, what you can do, you can just simply compile, and once your compilation is ready, whatever we have taught in the second tutorial, right, we will be using this callback method to limit our learning. If our loss is less than 0.4%, we'll just simply quit, and then you can run your model.fit by providing all the details. Okay, and definitely provide callbacks, okay, for quickest you know retrieval of your model, or else it will go to 10 epochs and it will probably take good amount of time. So we'll be stopping the model learning if the model's loss on training data set we get lesser than 0.4, then we will simply stop the learning. Okay, and this is the basic example how you can write ETL pipelines using TensorFlow datasets, and then how you can implement a basic machine learning model using TensorFlow dataset, right? So I'll just wait for this training to close and I'll back after that. As you can see that based upon our preferences set in the callback, uh, so as in after the second epoch, right, the loss is less than 0.4, so the training got cancelled automatically, even though we have given 10 epochs to complete the model training, right? Now in this section I have introduced a little bit of uh, method parameter checks, so that you can keep that in mind from the next tutorial onwards, when we will go deeper into the TFDS dataset portion, because this is very much important. It will be very much important in later point of your time when you will be doing any NLP or what computer vision related task in TensorFlow. Mostly we will be dealing with TensorFlow datasets for pipelining. Okay, so how to load a dataset? So tfds.load is the method. You have to provide the dataset name that is available in TFDS API catalog, and once you provide it, you just provide the split, which portion you want. If you don't provide anything, I'll just show what will happen. Okay, so right now in the very first case, let's say I'm providing the split as train, and if I run it, you will see that the train section got loaded with the image of 28 to cross 28 grayscale image and the corresponding levels, right? And now in the next set, same data set I'm loading, and this time I'm not mentioning the split. So what it will do, it will load all the splits available in the repository, which is you can see this dictionary. It contains the training as well as testing split. Okay, and you can see the same details of training and testing details, right? So in that way you can also separately load the test split. That will be your task probably if you want to do how to load the test split in this as a dataset object. Okay, and you can assert as well that it's this dataset dot train or dataset train. This particular object is nothing but a instance of our dataset module. So if you do a assert, it will not return anything. That means it's a true condition. Okay, and to check all the available list of dataset in tfds, you can use this list builder method. So if you call this method, it will return you all the available currently available dataset in tfds, which is ever growing, right? So you can see all the cmu code, I mean datasets. You can see the datasets corresponding to ImageNet. You can see datasets corresponding to media. You can see datasets corresponding to Hugging Face, and you can see various Kaggle dataset. Various datasets are here. All Hugging Face datasets are available. So you can, I think, and also some BigQuery datasets. I don't know exactly, but probably you can check, right? So these many datasets currently is supported by tfds. So you can use, I mean, you can just load all this dataset with this simple dot load method, right? Nothing you have to do. So your load, I mean, e portion is complete, extract portion is complete, right? With just a simple line of code, no flat buffer, nothing you have to write, right? And this info part I have already told you here, right? How you can check the info or metadata level information about the dataset by providing this parameter with info equals to true while loading. Okay, and apart from this, I have already told how to use dictionary versus dataset, numpy dataset. So if you use as supervised key, then it will load the dataset as a numpy array or numpy dataset, and you can then use this shape method to verify the shapes of the arrays. And in another case, if you don't specify this one like a normal load, then it will load as a dictionary, so this method will not work, right? So okay, I think this is a very good starting point for you to understand what is tfds. So we have learned today what is tfds and what is the basic importance of tfds in implementing etl pipelines in tensorflow. So once you get habituated, you just run one or two line of codes here, right? And get habituated yourself with tfds. In the next section of videos, we'll go deeper into all the available methods and functions of tfds, and we'll see how that can help us in building much more robust machine learning pipelines in tensorflow. Thank you very much.